Hi everybody, and welcome to a new major course in the Sound of AI YouTube channel. This time we're going to tackle something we've never done before, that is like speech synthesis. The name of the course is the Monster Text-to-Speech and Voice Cloning course. What's the main goal of this course? Well, the idea is that by the end of it, you'll have a deep understanding of how machines learn to speak, from phonemes and text to realistic voices and expressive AI speech. What that means is that by the end of this course, you'll basically have all the tools to go out and potentially build text-to-speech and voice cloning systems by yourself, because you'll have a good understanding of all the moving parts there. Now, why should you care about text-to-speech and voice cloning? Why is it important? Well, there's a number of reasons why I think that is something you want to study. The main reason is that voice AI is literally exploding. So you've probably heard of speech synthesis, voice cloning companies like 11 Labs or PlayHT. Also in generative music, there are a bunch of companies that deal with singing voice cloning, like for example Kids AI. The reality is that voice is kind of becoming the main interface between humans and LLMs. For example, I spend a lot of time chatting with ChatGPT. It's not just issuing commands to the LLM to do like what I want it to do. It's also that I'm having constant conversations, for example, in French, just like to practice my French. So as you see, the market for voice AI, and more specifically for speech synthesis, is growing very fast. So it's a very good and strategic idea, that of becoming an expert in text-to-speech and voice cloning, also because over the last 2 to 3 years, I've seen the number of jobs for voice ML specialists going up a lot. And the reality is that there aren't really many people out there who can do these things. So if you get to know text-to-speech, if you get to master voice cloning, you'll be in a very strong position on the market. But the problem that you have right now, if you want to learn text-to-speech or speech synthesis, is that there aren't really resources out there. Well, of course, you have the papers with all the state-of-the-art information, but the problem is that these papers are very advanced, because of course they are thought of for an audience who's already an expert in the topic. So all the information around voice cloning, speech synthesis is scattered all over the place. It's difficult to put together all the things, and to my knowledge, there isn't really a centralized place or a course where you can get basically a brain dump of all the state-of-the-art techniques and concepts. Basically, what I want to do is to create that resource, to create a course that's going to be massive and that puts together all of that state-of-the-art information regarding speech synthesis. And we're going to cover both text-to-speech and voice cloning. We'll see a little bit more in detail what we're going to cover in a second. But the point that I want to make here is that I want to create a synthesis of all of this information that's scattered all over the place, to make it in a way that's easy to process, to get into, even if you are not an expert, supposedly, in this space. On top of that, I'm also going to bring my first-hand experience building these models. And so yeah, that's basically the idea. And that's why I called it the Monster Text-to-Speech and Voice Cloning course. Who's this course for? Well, this is a technical course. Ideally, the people who should take it are ML engineers, ML researchers, audio programmers who have an interest and a little bit of a background in machine learning, especially for audio. That would help a lot. developers, again, with an interest in audio and machine learning. But it's also open to engineering managers and product managers as long as they have somewhat of a technical, not necessarily background, but at least understanding that they are comfortable with technical topics. Indeed, this is not an entry-level course. In order to take it, you have to have a certain background already. Here I list some of these things. So I'm not going to get into basic ML concepts like embeddings or training. I've covered this in other videos. But here I'm just going to assume that you already know about that. Also, I'm not going to specifically talk about specific deep learning architectures like transformers or GANs. Of course, we're going to cover this because many voice cloning or speech synthesis systems do use transformers or GANs, but I'm not going to get into the tiny little details of all of this. Rather, I will assume that you already have an understanding of that. If that's not the case, don't worry. I've covered especially transformers in a lot of detail in another course, in another series. So every time there's something that I feel is fundamental to know to a deeper extent, and I can't cover it for like time constraints, what I'm going to do is I'm going to link you to one of the videos that I already published that covered that specific topic. Or at least I'm going to give you resources where you can learn a little bit more about these different topics elsewhere, perhaps. Also, another prerequisite is going to be basic audio digital signal processing. You should be familiar with concepts and constructs like the power spectrum, spectrograms, and waveform. Again, it's not super necessary that you know all the nitty-gritty details in terms of the math behind it, but having an understanding of this is going to be very important. Once again, these are all things that I've covered in other courses, so I'm going to just point you towards those videos in case you want to learn those foundations before you go deeper into the topic at hand. There's no need to have coding experience for this course. But there's one thing that's extremely necessary, and that is a willing to learn a ton. And that's because in this course, we're going to cover a lot of things, a lot of topics, and you really have to be curious and wanted to learn more. If you've been around the Sound of AI channel for quite some time and have already watched other courses that I have here, you know my teaching style, and that is giving you the intuition and then going down deep into the theory. Of course, I love to give you the theory and in quite depth, but at the same time, I think it's extremely important that you get a very high level understanding and intuition around all the topics that I cover. That's been the philosophy that I've always used when I teach in this channel or otherwise at university. And I'm going to do the same thing for this course as well. What that means in particular is that we're going to have some big picture conceptual videos, like for example, introducing the concept of neural audio compression or codecs. I'm going to give you a high-level overview of what these things are, how they work, what are the use cases for them, and then we may have one or two deeper videos that perhaps zoom in onto specific systems. In the case of neural codecs, we may just look into encodec or soundstream. And those videos will just zoom in and give you all the nitty-gritty details. So you'll have the high-level concepts in one video, and then we're going to zoom in into the architecture of the specific system in dedicated videos. I'm also going to give you pointers to papers, open source models, implementations, and demos so that you can dig in more by yourself. This is extremely important because there's not going to be any course at all for a topic as complex as speech synthesis, or for that matter, any AI big like use case or topic, that it's going to be enough exhaustive to get you to mastery. In order to get you to mastery, you start from a place like this course, that's a sort of like synthesis, but then you go your own way and you dig deeper. So that's how you become a master in a topic as hard as text-to-speech, for example. We're not going to have any code in this course, and the reason is quite simple. These systems are state-of-the-art, and to code any of this from scratch would take an incredible amount of time, and that's outside the scope of this course. Of course, in a subsequent playlist or series, I may just focus on a particular use case and give you also the code implementation, but that's not the point for this course. In this course, I want to give you the theoretical and intuition tools so that you understand how to build these systems. And then you can just go out, see a few implementations out there, and once you have the theory and the intuition already crystal clear, it's going to be quite easy for you to actually build the systems themselves. And I think like this is something like that I've seen time and again, also like with the teams that I led or that I consulted. It's extremely important for people to have a deep understanding of the theory and the intuition. Once you have that, the coding part is simple. It's just mechanical. The hard part is to understand the thinking behind it. So yeah, for this course, no coding. Okay, I've blubbered for quite some time regarding abstract things, but what are you going to get out of this course? What are you going to actually learn? Well, I've structured this course into 3 different parts. Part number 1 is foundations. So the first thing that we'll cover is how humans speak. You'll understand how we produce speech. And that's going to be extremely important because that's going to be foundation for a lot of the systems that over time have been developed for text-to-speech. And it's also going to give you an understanding of what we do with technology in order to simulate or to recreate the output of what we do as human beings when we talk with each other. Next up, we are going to look at how machines process text and phonemes. And why is this important? Well, we are doing speech generation. Of course, the audio generation of it is extremely important, but we're not just generating any audio or any sound or music that's abstract and detached from text. Well, with speech synthesis, text is central to it all because we generate speech based off of a script, a text script. So we really need to understand how machines can process that information. So now, once we have all of that foundations laid out, we're going to get into the core technologies. And we're going to be very thorough here. We're going to start from traditional text-to-speech techniques like concatenative synthesis, and we're going to move all the way to neural vocoders, like for example, hi-fi GAN. If you've been around like this field at all, probably you've heard like that architecture array. It's quite famous. Right, so after vocoders, we're going to jump into neural codecs. Basically, that's neural audio compression that allows you to get to discrete audio tokens. Some famous, very popular architectures, neural codecs, are encodec and soundstream. So we're going to cover probably both of them. But why is this important? Well, neural codecs are important because basically what they do is they take a waveform and then they compress it down. They reduce the dimensionality of that initial waveform into a token space that's way lower dimensional. And now, given you are now in a smaller dimensional, lower dimensional space, you can do whatever generation you want in this token representation, and then you can go back to waveform space by doing like the inverse of the encoding, so the decoding that's done once again through the decoder of encodec or Soundstream or any other neural codec out there. So this is an extremely important component of today's state-of-the-art text-to-speech and voice cloning systems. So once we're done with neural codecs, we're going to jump into another topic that's extremely important: self-supervised speech representation. These are systems like WaveLM. What are these things? Well, these are they basically use representation learning, and they will allow you to basically get representations of, for example, the timbre of a person, or representation of certain emotions in speech, or representation of prosody, accent. So basically we can use these systems for creating a fingerprint of all of these more advanced features of speech. These self-supervised learning representation speech models are not only used in speech synthesis, but they're used also for automatic speech recognition or for speech enhancement. This is a theme that will recur throughout the course. We're going to be covering a lot of components, a lot of tools, and the great thing is that all of these tools that we'll be covering are not only tied to speech synthesis, but these are the same tools, the same building blocks that you can use for other use cases in speech or music generation, for example, say generative music, or in speech enhancement, noise cancelling, or speaker diarization. Yes, this is like very, very powerful, because once again, these are tools that you can use also for other use cases. And you'll learn it here once, and then you can reuse them somewhere else, which is really cool. Now, once we're done with this self-supervised models, we'll move on to what's state-of-the-art these days in voice cloning and text-to-speech, and that is codecs-based generation. These are systems like Valley, for example, and they basically work on a very high level. How I mentioned, like they worked earlier, like when I was talking about neural codecs. So you have neural codecs that do the compression onto a token space, a lower dimensional token space. Then there are like transformers, for example, or complex architectures that you can use to do the generation in this token space. And then once you're done with this new sequence of tokens, you can go back to waveform space once again using a neural codec, but not the encoder this time, but rather the decoder. Right. So by the end of this part, you'll have a really strong understanding of the state of the art in voice cloning and text-to-speech. We're also going to be covering things like zero-shot learning for voice cloning, or few-shot learning, and basically fine-tuning and all of this particular like variations on a theme or like speech synthesis. Okay, so what next? What's part 3? Well, part 3 gets into the research frontiers. So what's been actively researched these days. Specifically, we're going to be covering models that are able to factor in more complex aspects of speech, like emotion or prosody. And as we'll see, prosody is the music in the speech, the way we articulate speech rhythmically and melodically. And we're also going to look at how we can use some of the more or less similar techniques also for modeling accents. Then we're going to do a little bit of a dive into voice singing. After all, the Sound of AI is primarily an AI music channel. And so we'll just like quickly touch on how we can use voice cloning but applied for a sung voice, so for voice singing. And we'll also look at speech-to-speech generation. It basically like moves like from one speech in a time break and then moves like directly like onto another speaker. And finally, we'll cover conversational and voice agents. We'll see what's the buzz all about regarding like this agents, voice agents, and see what some of the applications and future opportunities and possibilities are out there. So here we go. That's the plan. And as you see, it's quite thorough, it's quite massive, and it requires like quite some time to go through all of this. This video is offered by myself. If you're building an AI music, voice, or audio products and are facing high-stake technical challenges, I can help. I've been building AI audio companies and products for 15 years. I now offer consulting on architecture, R&D, product strategy, and hiring, so you can avoid costly mistakes and months of wasted time. Visit valeriavelardeadvisor.com to book a strategy call, link in the description. Now back to the video. Where can you get all the learning material? The learning material will be basically like reading lists, as well as, of course, the slide presentations as the one that you're seeing right now. It's going to be like completely free and open on GitHub. So here there's a dedicated repo here. And of course, like it's empty right now, but at each video that I publish, I'm going to add like the associated learning material. And once you're here, I would really appreciate it if you could just like star the repo, just like to demonstrate like that you appreciate like the work that I'm doing here. Okay. There's also a possibility for you to discuss the course topics. So where can you do that? Well, you can do that in the Sound of AI Slack community. If you're not there, well, you're missing a lot, because it's a very friendly community focused on all things AI music, AI speech, audio, all those things that intersect some form of audio and music. Specifically, I've set up a channel that's called TTS Course. So if you are already a member of the Slack community, you have to opt in into this new channel. If you are signing up for the first time, you should already be signed up into TTS Course the moment you get in. And in order to sign up, you just go here, the Sound of AI Slack community, and you have a link that brings you to this community here. And as you can see, it's a very, very nice community, more than 11,000 people. It's very friendly. I obviously suggest you like to get in there, besides the feedback that you can get for this particular course. Okay, but beyond the Slack community, I also suggest that you leave comments directly under the YouTube videos, and I'm going to try to answer like as many questions as you guys have. So I would really appreciate it, like if you could like leave comments. Well, that's also like comments of appreciation, because they help a lot with the algorithm. But if you have questions, yeah, consider like leaving those like questions in comments, and I'll try to answer those. Okay, how do you get the most out of this course? Well, first of all, I highly suggest that you watch actively. Don't just follow the videos passively and that's it. You're not going to learn. You're going to feel you're learning, but you're not really going to learn, okay? Rather, just pause, think through all the things that I'm saying, and sketch the flow of the arguments, of the architectures by yourself, okay? And then beyond that, go and study at least some of the papers I cover, some of those architectures, because they're going to give you another angle that's going to be very important for you to master the complexity of speech synthesis. Also, I'm going to point you in towards a number of models and open source implementations on GitHub or Hugging Face, go check them out. Play around with them, okay? Because you're only going to learn as long as you are going to do the work, do the playing around. That's the most important thing you can do. And I also highly suggest you to follow all the videos in order as they come out. If you're seeing this 1 year from when I'm posting this, or 2 years, of course, the course now is already done and you can go through all of them at your pace. But in any case, I suggest you follow the order, because there's structure in there that makes sense. I'm trying to make this complex topic as easy as possible for you to get in comfortably and moving through the complexity, bubbling up onto the higher levels of complexity. The most important thing though is that you put the time in. These are not going to be easy lectures. Well, the higher level intuition, yes, but the other ones will be deep. And there's no other way around it. You have to put the time in. Put the time in for following the lectures. Put the time in for studying the papers and for playing around with the code on your own time. This is an extremely complex topic. There's no shortcut. You have to put the time in. Yeah, let me tell you a little bit about the course pace, my pace, as well as what I suggest for you as a pace, especially if you are following the course as I publish it. The idea for me is to try to publish 1 to 2 videos per week, depending, of course, on external factors like work, for example, and other constraints. But the idea is to keep this pace, which basically will put us at 3 to 5 months to go through the entire series, to publish all videos. My suggestion to you is to put at least 3 to 5 hours of study per week. If you do that, and you do that consistently, and you follow all the resources that I share, I promise you, you will be in a very good place in terms of your understanding of text-to-speech and voice cloning. You're going to be better than 95% of the people who do this. I know. As you've seen from this course overview, I'm putting in a lot of time and a lot of effort. And the reason I'm doing this, and the reason I do The Sound of AI, is because my mission is to try to bring you excellent education for free. I strongly believe in this, and it's one of the things that really motivates me the most. So if you share this mission, if you share the same values that I have, I would really appreciate it if you could subscribe to the channel, because it's going to help me a lot in spreading the word. And at the same time, it also costs you nothing. Cool. I think that's all I wanted to say for this course overview. So we're ready to go. So I'll see you quite soon in the next video so that the party will get started. Bye for now.